To learn how to control corrosion, it's important to understand how the process works. When metals are mined, they are generally found as oxides. By adding energy in the refining process, metals become more useful for manufacturing, but also more reactive. Corrosion is simply the process of refined metal reverting back to their stable oxidized state. There are several processes by which corrosion occurs. Two types most relevant to water utilities are galvanic and electrolytic corrosion. Galvanic corrosion is the process harnessed to make an electric battery. There's some chemistry at work, but the basic process can be demonstrated without it. A galvanic cell requires an anode, a cathode, an electrolyte, and an electronic path. An electric current is generated where the anode gives up electrons that flow through the electronic path to the cathode. The anode experiences corrosion, while the cathode does not. It's important to note that the flow of electrical current is opposite the direction that electrons are traveling. A galvanic cell can also be created with a single metal or alloy immersed in a non-uniform electrolyte. Again, corrosion occurs at the anode. In a single piece of metal, the metal itself becomes the electronic path. Galvanic cells can easily be found in a water distribution system. For example, this valve is made of several types of metals. In the absence of a protective coating, a galvanic cell can develop and corrosion will occur at the anode. Pipes can also form galvanic cells. Surrounding soil containing water forms the electrolyte. Variances in the soil or pipe composition can create electric flow and corrosion at the anode. Electrolytic corrosion also requires an anode, cathode, electrolyte, and electronic path. However, this cell does not generate its own current. The current is introduced by an external direct current source. Trains and subway systems are a common source of stray current, as is electric welding equipment. 5 types of corrosion are commonly found: concentration cells, pitting, impingement corrosion attack, microbiologically influenced corrosion, and atmospheric corrosion. Concentration cells often develop at crevices and are caused by a difference in oxygen levels between the crevice and surrounding areas. This is called an aeration cell. Metal near the lower oxygen concentration will become anodic and corrosion will occur in the crevice. This pipe shows pitting corrosion, which happens when a protective coating or even the metal surface itself breaks down. Some metals can form their own protective surface through the manufacturing process. When this surface is damaged by impact, such as a strong stream of water, impingement corrosion attack may occur, although this primarily occurs internally. Microbiologically influenced corrosion involves colonies of microorganisms or biofilms on pipe surfaces. Organisms can create electrolytes favorable to galvanic corrosion, aeration cells, and in some cases attack the metal chemically.